Okay, so today we're gonna learn a little bit about reverse engineering, and welcome everyone. So what is reverse engineering? So imagine a complex machine. Reverse engineering is like taking that machine apart, examining its inner workings, and understanding how it produces its output. In the software world, it's the process of analyzing a program to understand its logic, functionality, and potentially uncover its vulnerabilities. To put it similar this way, we can see that our machine can only understand basic command, which is 0 and 1, and so they use a special file, which is executable files, in order to execute the commands that are given to them. So sometimes we use these executable file and reverse the process of compilation to get the assembly code in order to crack or to detect any vulnerabilities problem, maybe to check if it is a spyware or not. And what is OllyDbg? OllyDbg is a powerful debugger specifically designed for Windows. It allows you to inspect a program's execution in real time, step through its code line by line, and analyze its memory usage. OllyDbg is a popular choice for reverse engineering due to its ease of use, intensive features, and large community. And you can go ahead and download OllyDbg using this link. Why OllyDbg? While other tools like IDA Pro and Jira exist, OllyDbg offers a good balance of features and accessibility. Its intuitive interface and focus on debugging make it a great starting point for learning reverse engineering. Yeah, and it's free. And we will learn reverse engineering through a very small code challenge. And what are crack means? Crack means are small, self-contained applications designed to challenge your reverse engineering skills. They often contain deliberate obfuscation or protection mechanisms to make it difficult to extract their functionality or bypass their security checks. But our crack me is similar. When the program starts, it will generate a random password between 8 to 12 random characters. This password is the same throughout its runtime. Your job is to guess the correct password. If your password is wrong, a message your guess is wrong, try again will appear, and we'll complete the challenge by finding out the real password. Here's our program. So yeah, it only contains a few lines of code. Okay, so go ahead and give it a try before seeing the solution. And I will demonstrate the solution right now by using OllyDbg. First up, we have to open up our application, and it will ask for administration. So here's our application's appearance. The first tab or the first window to the top left is our code in assembly language. On the top right is our registers. The bottom left is our dump memory, and finally is our stack. To load our application, go ahead and click open. Here I will select readme.exe, and by pressing F9, we can run the application, or by using this button right here. And here is our program. I will try a wrong password. So a message appear, and your guess is wrong. Try again. First, we will have to see our executable modules by clicking this button. Usually it contains all the libraries, dependencies, or DLLs have been loaded into our program to run. But we will mainly focus on our main thread, the first one here. We know that there's a message, your guess is wrong, will appear. So there will be a memory that is responsible for that string, right? And by clicking the memory, we can see our application memory map. And by using shortcut Ctrl B, it will open up a search window. And okay, we find our first match. Your guess is wrong, right here. But there might be many memories that have the same values. So we have to check whether or not this location right here is what we are looking for. I will type in to see if this action has any effect on our program. Well, sadly no, this is not what we are looking for. And I will go ahead and search for the next one. Alright, here is our second match. I will do the same thing. Alright, so this is what we are expecting. Your guess is wrong. So we know that this memory right here is the memory location that this program used to display that string. And I will go ahead and set a breakpoint here whenever our program tries to access this location, memory on access, and hopefully we will hit our breakpoint. Alright, and we hit our breakpoint. It appears like some library is trying to access this memory location, but this is not our main program. I will go ahead and skip this by pressing F8. Alright, so we are back into our main thread of our application. So it is called just right here. Look like it's calling something here to retrieve the user input, and then it will move some value into the ECX register and the EDX register. Then it will call some function from another library, and it will test the result. From that result, it will use a conditional jump based on that result. So we know that our program have to compare the two strings. The first one is the user input and the real password. And based on the result, it will continue its execution. So from that knowledge, from that awareness, we will suspect that these 4 lines of instructions, they are responsible for checking the password. And I will go ahead and put a breakpoint here by pressing F2. And I will remove the previous memory breakpoint and rerun the program. All right, we hit our breakpoint. I will go ahead and press F8 here so that our values are loaded into our registers. We can go ahead and look what are the values that these 2 registers are holding by follow in dump. We can see that it is encoded in Unicode. Password, this is what our input. And I'm guessing that the second register is the actual password, right? So it's a random sequence of characters assembling our password, right? Yeah. I will go ahead and jot this password down. So second check, IERGUY58BC, right? And let's continue the execution of our program. I will remove this breakpoint. And this time I will try to use this password. All right, so congratulations, you guessed the password. Yeah, and we complete our code challenge. And from now it's very simple to crack this program by remove that conditional jump by filling some empty byte to remain the size, and then save the modified version of the program. And whenever we run our program, we don't have to input the correct password anymore. It will always run into the success message. And yeah, here's the detailed solution for this. And final thoughts. While reverse engineering is very powerful, but it's very hard, considering nearly impossible, to reverse engineer complex real-world applications due to many factors. For example, complex architecture, or the heavy usage of external libraries, dependencies, and more programs needs to communicate using network, server, other application. So it adds another difficult layer in order to understand the program, as well as many threads, DLLs. So how can we prevent it further? As a developer, we can use the technique obfuscation by renaming variables, changing the order of instruction, make it nearly impossible to read and understand assembly code. We can try to use some anti-debugging measures and some other protection mechanisms like encryption, code signing. Yeah, and that's all. Thank you very much.